Right, hello. This is just intended to be a few basic comments on my experiences with this particular A-level. I think for the most part they'll just be fairly simple statements really. There's quite a few little things that people are getting wrong all the time, so that's probably what I'll talk about for the most time rather than large-scale problems. But you've got the website down there. If you go there, you can get the full model answers if you want to have a look at those, and also it gives a link to the where you can get the exam paper itself. So if I can start with, for example, number 1. Can you see that? Okay. Yeah, I mean, I should also say that you can obviously freeze these videos and so on, so I can probably scoot through them fairly quickly. So I don't really need to hold this too long. Hopefully you can just read the basic ideas of that. Now, one thing I really need to say about this is on the part A. People got the right idea, but there's always one comment that people miss out, which always loses them a mark. Now you can see that basically what you just need to substitute in for 2 points, and if one is a negative value and one is a positive value, then you know that there is going to be a root within those two intervals with just one rider. You know, you'd have sort of 2 points. You'd find out one, substitute your value into the, I don't know, say this is 2 and this is 3. You'd substitute this value into the function, and that might come out positive. You substitute this value into the function, and that might come out negative. And you can say, therefore, because there is a change of sign, then there is going to be a root within this interval, which is what's being asked. But the one thing you need to also add is you need to add that this function is continuous. Okay. Well, hopefully the function is obviously continuous. So you say, okay, there's a change of sign. Well, before I say that, I should also say, I mean, this might seem a little thing, but you do need to show that you know what you're doing here. You don't just sort of find out those two values and therefore say, therefore there's a root or something like that. You need to actually show what you know, show the examiner that you know what you're doing. So you find out these two values. You therefore say, there's a change of sign between a positive and a negative. There's a change of sign that implies that there is a root in between these two values. But you do need to state that the function is continuous. And as I said, hopefully the function is obviously continuous. So you can just say the function is continuous along with the change of sign. Therefore, there is a root in between these two values. So you do need to put the word. You do need to specifically state that the function is continuous, and also put that final conclusion in that therefore there is a root in between these two values. I mean, practically that's the one. I mean, this might seem a little thing, but practically everyone does actually. Well, when I say everyone, the majority do omit this idea of stating that the function is continuous, and therefore they lose a mark. So it's worth stressing that. Now, number 2. This is actually done fairly well, so I won't say too much about this. I'll just need to look at B, which says find f of -1. The expression for what it's worth was sorry about that, just managed to drop everything on the floor. The original function was and f of minus 1, answer for that is 4x plus 3 x minus 1. Okay, so most people seem to be able to get that and so on, but what they did not state was that you need to stick that in for full marks. Yeah, looking at this denominator here. Right. Question 3. Now this is prove that. The one thing I need to say about all these prove things, where it says prove, you need to stick in all the steps. You know, you don't need to. You need to show that you know what you're doing, and this is quite important here actually, because what was it 2a? What a lot of people did was go straight in equals cosine squared a minus sine squared a. Okay, which is technically correct, but it's not really what. Again, this might seem nitpicking, but that's not really what classed as a standard identity. What you really need to put down initially is cosine okay, that is the sort of standard identity, and that's what you need to put down. If you'd gone straight onto that, I have to tell you that you would have lost a mark. You need to start from the basic identity and then make the step from that to that somehow. You know, just note that follows on from that. It's little things like that. I mean, I don't know how you can. How shall I state this? I mean, because you're proving something, you need to put. Show all the steps. That's more or less what I've said already, and it's just the basic step right at the beginning is this standard identity. You need to put that down in order to get the full marks. Now the other thing is you had the integral. The integral is 5 minus 4 cos squared 3x. Now, okay, most people seem to do this okay, but the important thing to notice, excuse me, the important thing to realise is that you can't just do that in the standard way, in the sense of the way you integrate x squared. You know, you can't just raise the index by 1 and then divide through by you know, you can't just raise that up to 3 and then divide through by 3. What you're going to have to use here is an identity. The identity I know I'm going to use is okay. I can say I can manipulate this, so I can use that. So what I would do is I'd say okay, integral 3 minus 4 cosine squared 3x minus 2. Strictly speaking, there should be a dx on the end here, but well, you know, I want to be really pedantic, be like this. And then that would become okay, so that's more or less it. So that becomes equals 3 And I don't know, I'll leave that for you. The integral of cosine 6x is minus sine 6x over 6, and so on. But the important thing I wanted to note here is that what I've done here is I've got it all down to this stage here, and then it's only then that I'm going to integrate. What some people did was they sort of started integrating the number while they were still processing the this right hand side bit, if I can put it like that, which is not incorrect, but it just gets a bit of a mess. This is mathematics where we want to keep everything elegant, so just process the entire integral in one go and then do the integral in one go. Don't have one half the integral being processed at a more advanced stage than the other half. And I can just go back to this is an important point here. Where it says down here, it says sorry. It says find the exact value, okay? So I can tell you the exact value of the integral I've just done now is pi over 8 minus root 2 plus 2 over 6. That's the integral, and that's your answer if you want to work through that. But that is the exact answer, that's what it asks in the question. If you get your calculator out and get an answer for this, then it's going to be wrong, because you can't use a calculator to find an exact value for pi, neither can you for root 2. So when it asks for an exact answer, it has to be in this type of form. Use your calculator and you're going to get the wrong answer and you're going to lose marks. That happened more than once in this particular exam question, so that's why I'm stressing it. Right, question 4. Again, this is quite a lot to take in. What am I going to say about this? Right, part B. I'm leaving it whether you can see where the possible error is here. You can notice with the top value, the top formula, n equals 125 minus that expression. Where it says in B, the total sales of the phone was 100,000. The major error there was that people would put the 100,000 into the formula at the top, whereas the formula at the top is giving you it in numbers of thousands. 125,000 has been entered as 125, so the 100,000 in B should be entered as 100. If you entered 100,000, then you'd lose all the marks straight away. So that's an important thing to notice. And C, find the rate of increase in total sales. Practically, I can tell you that practically everyone got this wrong, the final answer. And can you see why that should be? basically because the answer that dropped out was 4.73. But that is not the answer. The answer is 4,370. Practically everyone just put down 4.73, which is wrong. So they all lost a mark there. Well, practically everyone lost a mark there. Now, D, I can keep it like this. Whenever there's need to write something in English or something, you can always guarantee that things are going to go pear-shaped. And likewise, what happened in D. I mean, all that happens really is by consideration of the formula right at the top. The maximum, as time increases, or as as time increases, n is just going to go to 125. That is therefore inappropriate to model sales, where you need to reach a value of 150 or 150,000 to be more precise. But but 150 will go in as the into the equation. So that's really all you need to know. The as time increases, the equation will have a maximum at 125. So therefore, it's inappropriate to be used for if the sales are expected to reach 150,000. It's just amazing that some people can't write sort of coherent English to just express that. Right, 5. Can you see that if I just lay it down on the desk? Yeah, that should be okay. Yeah, so this is just I apologise for this. Yeah, I mean, this is pretty straightforward. You just differentiate this according to the quotient rule, and as long as you've got the done it basically okay, you need both terms in the numerator had to contain an x and so on, which you can then factorise to get this expression here. One thing again, does x for yeah, it doesn't say exact here, but the turning points will be given in terms of E, so that you need to stick the E down rather than using your calculator again, as I said in the last question. What it says down here, find an appropriate limit. Well, basically the two of the turning points will be x plus or minus E minus k. So an upper limit for the value of k is that the upper limit will be that k is less than E. In that sense, E would be the upper limit. In order that this expression doesn't become negative. But the little thing I need to point out here is that you need to say the upper limit, so it's k is less than E, or you can say the upper limit is E. But what you definitely do not do is you don't do that. Not by itself. You could say, okay, the upper limit is k equals E or something like that. You might get away with writing that down if you put an explanation in as well to that effect. But just putting down k equals E as the answer will not get you anywhere, because that's really expressing the limit there, not that. Right, this is a bit of a nasty question involving logarithms, but it's needs a bit of thought. I mean, initially if you've got log 10 equals 4.5 minus 0.006t. So if you're taking the antilog, s equals 10, 4.5 minus 0.06. In that case, 6. In the first case, the 2, isn't it? So, so you basically anti-logging it. S, that becomes s, and that becomes 10 to the power of that. Because the t in the first bit is 2, then I can substitute that t. That'll give me the answer. When it says find the complete equation for the model in the form, you're basically doing the same thing again. You're going s. You go from there to s equals 10. 4.5 minus 0.006t. Okay, so the first bit was when t equals 2. Sorry about that. This is a t. That's the general formula. That first bit is when you're for part A is when a equals 2, but this second one is trying to find the general formula. So you just need to realise then that can separate out 2.45 10 minus 0.006t, and go from there. The the other little bit of thing you need to know is 0.006. I can separate out like that using basic indices. So you work out the figures for those 2 powers of 10, and that's your answer. The answer for what it's worth is yeah. I'm resisting the temptation here to go on about every little thing that crops up, because one thing that some people try to do is to take that down to the bottom, as a denominator, with the plus, with the positive value of this index, which is correct, but it just messes the whole thing up. It's just best to keep it in that form, so it follows straight through to the answer that you need. Right, the range, part A asks you to find the range. Well, the range relates to the y values. Okay, the domain relates to the x values. The range relates to the y values. It's just the range of values that y can take. So here it's just between 0 and 9. You then then differentiate just using the product rule, fairly straightforward. C started to get a bit of a mess. I mean, if you've got an expression like this, that will then enable you to find out the stationary points. You can see it in a hand waving way from the diagram that you've got a stationary point there, a stationary point there. I mean, the actual numerical values of these stationary points are going to be identical, that with that and that with that. So you've got 2 expressions here. That comes out, I can tell you, to so if you accept those factors equal to 0 in the normal way to find these stationary points, it would actually come out to x equals root 3 over 2 and x equals root 7 over 2 plus or minus. So you can see in a hand waving way from the diagram that the one you want to go for is this one here. I mean, I should have mentioned what's been asked in the question first. It says, given that the line y equals k, where k is a constant, k is greater than 0, intersects the curve at exactly 2 distinct points. Well, y equals k is a horizontal line on here, so I'm looking for a line somewhere between here and here. Okay. The important thing is that if that line intersects what are we after? Sorry. If the line goes through those 2 points, then it's going to cut the line at 4 distinct places. So I'm looking for a line that is above that. The value of those stationary points are the limit, if you like. So it's got to be above that and less than y equals 9, because obviously at that point there it's only going to cross the line at 1 point. So you've got these two values of x. I mean, it didn't happen so often. What usually happens, well, not usually happens, what often happens in cases of trying to find stationary points is that people will find the first derivative, set that equal to 0, and then find out the x values, and then come to a stop. Whereas that's not the answer. You know, when you're trying to find the maximum or minimum, the actual values that you need are the y values, not the x values. So, you know, that's a good point to mention in passing for all problems of this type. You don't just find the x values, you then stick it into the original function to find out the y values, which are the stationary points that you're trying to find, if that's what you're being asked for. And that's what you're going to do here. You need to find the values of these points here. You'll stick the x values into the function, which has a square sign in, has a squared terms in, so this plus and minus square root thing will vanish. It will just become 7 over 2. And the answer, well, that's the one we want here, the one corresponding to these values. And the actual answer that will crop out will be leave 16 minus 2. So a couple of points to mention here are, this question again asks for the exact values. So it has to be this. You can't try and work out the value using a calculator, because that becomes an approximation. It will not be the exact answer. The exact answer is this. And it starts to become a bit more serious here, because often when you fail to put the exact answer in, when you use your calculator and instead of finding the exact answer, you might lose 1 mark. But you can see the nature of the question here. If you're finding the not finding the exact value for this, you've done it sort of mid-calculation in a sense, so you risk losing more than 1 mark. So an exact answer can only be in this form. You can't use your calculator to find out an exact answer here. And the range, I've already said that really, it needs to be this. It's not a less or equal to, it's a less than or whatever. X is greater than that, but less than 9. For the reasons I've just said, really, it can't be x equals 9, because that'll only cross it at 1 point. We're looking for a situation where the line only crosses at 2 distinct points. Now this one, Obviously there's various different ways to doing identities like this. The way I would recommend is to realise that cosec can go underneath as sine, as a sine term. So I produce okay, so that cosec squared 2 theta bit has gone on the bottom as sine squared 2 theta, and I've played around with this using just taking that 2 over to there, so that becomes this. Now the point is here, from here in, I can just use standard identities. That becomes 2 minus 2, 1 minus sine squared theta over 4 that's right, isn't it? Yep, because that's equal to that, and that's equal to that. Just got to be a bit careful here on the arithmetic. A few people wrote that down as 2, whereas squaring the idea of squaring the expansion of sine 2 theta means that you end up here with a 4. So yeah, I'll just do it for you. 4 sine squared theta over 4 sine squared theta cosine squared theta. You can see what's going to happen. Cancel top and bottom. It becomes 1 over cosine squared theta, which equals sec squared theta, which equals 1 plus tan squared theta. Now again, going back to what I said before, you're trying to prove something here, so it's important that you stick down all steps. Some people left that out and went directly from there to there, which will lose you a mark. I mean, that's what you're trying to prove. How do I know that you haven't got that far and then we're just clueless what to do next? So you just said, oh, I'll stick down the answer, which is given in the question. You know, you need to show the examiner you know what you're doing. So that is equal to sec squared theta, and then you use an identity. And that going from there to there is just a standard identity. So you do need to show that. Now the second part, you use that to calculate this particular equation. So the equation there, using part A, reduces down to this. Now, although it might seem fairly trivial, the first part A is in theta and part B is in x, so it's useful to make sure you know you're using the correct designations here. Now, what you do here is, I mean, again, it might seem obvious to some people, but you know, I'm really sort of going on the experience of what mistakes people were making. I mean, the thing is, that's just a standard identity from what we've just stated already. And then, you know, from then on, it's just a quadratic equation. You know, some people are trying to fiddle things around in, I don't know, terms of sines and cosines and things like that. Which, as long as the arithmetic is okay, you'll get the right answer. But yeah, that is the straightforward method to use. It's worth noting here that that identity is not hard to remember. Actually, it's the very basic identity is this. That's, you should all know by this at this stage, that identity. Now, if you divide that through by sine squared x, you'll get one identity, and then if you divide it through by cosine, you divide this by a factor of cosine squared x, you'll get another identity. That's what one of the identities that will drop out. So you only really need to know. You only really need to know this particular one. This one is derived from that. As I said, the other one involves cosines, cosecs and cotans as well, which is not used so often, but you don't really need to learn it. You just need to know this one here. So one other thing I need to say while I'm on it, the answer then, because you're getting an answer in terms of sec at the end of the day, I can tell you that the answer is sec x equals 4. That's the answer you're going to get to that particular equation. Therefore, cosine x equals 1 over 4. And that's particularly useful. If you ever got a choice in trigonometrical equations, whether to put it in terms of sine or cosines or whatever, then you always try and put it in terms of cosines, because the answer is always nice and easy. The general formula is something like this. We're dealing with in degrees, so it's n times 360 plus or minus whatever the inverse cosine is, i.e. the inverse cosine here is 75.5, a quarter. So it's within the range that we're after, which is 0 and 360, I think. So n equals 0 is the trivial one. That'll give you 75.5. And then I go around again, and then it's n is 1. So that's 360 minus 75.5, which is 284.5. I'm ignoring the plus. I'm ignoring the 360 plus 75.5 because the range that we wanted is between 0 and 360. But you can see how easy that equation is to find any number of values for the principal, any numbers of values for cosine that you require. Alright, question 9. Is that okay to see? Yeah. So to start off, say the value of k. Well, you need this value to be, you need log x plus 1 to be greater than 0. So therefore, x has got to be greater than minus 1 in order for the log to be greater than the log expression here to be greater than 0. So that'll give you sorry, what we're trying to find? We're trying to find k, aren't we? So k equals minus 1. Yeah. X has got to be greater than that value in order that expression is valid. When we come to this expression down at the bottom, it says use algebra and show your working. Find the set of values of x such that is true. Now, in mathematics, the most elegant mathematical way to do it, or the most appropriate way, if that's the correct term, is to square both sides. But that normally gets us into really unmanageable algebra. So the best thing to do is just split it into two. Take the positive side, positive left-hand side, and equate that, or say that's greater than 3, and take the negative left-hand side and make that make that greater than 3 as well. So do it in two separate operations. The one thing I need to just notice here in passing is that well, I won't give it in full, but the bottom, well, I will put it down in full actually. X minus -1, and x is less than e to minus a quarter minus 1. Yeah. Fiddling around with two separate operations, as I've just said, will give you this expression here on the right hand side, and you need to recognise that in order for that to be greater than 3, you're looking for this line where it's greater than 3, i.e., that's 3 there. Then you're looking for it up here. So the corresponding values of x will be greater than that and less than that, which I more or less put down. But that is not the actual full answer. What you need to also put down is that to get full marks, you need to stick down that x is greater than -1, because that's what you've got from the diagram. It's obviously less than that value there, but it's also greater than -1. So that's what you need to put down for full marks. And the last question here. Again, I won't do it in full here, but part A involves trying to find the inverse sign, whereas what you're going to put down is the inverse sign. Well, it's actually the inverse sign of a half, which is pi over 6. One or two people put down 30, but I just need to stress here that we're dealing in radians. Anything like this, you're dealing in radians, not degrees. So then you've got the derivative. You've got x equals sin squared 4y. So dx over dy. You can always do this in as the chain rule if you're unhappy with it. But the more you get into that, you should be able to do this in one go. So what you do is you say 2 sine 4y. You then differentiate the sine 4y, which will give you cosine 4y 4, which will equal 8 sine 4y cosine 4y. So I've done that all in one go. Which, if you're not happy about it, do work it out using the chain rule. And again, this is also equal to 4 sine 8y. That's correct as well, but that might not be so useful as for what's going to follow, because what you need to do now is to work out this expression for dy by dx. So that's dy by dx. So that's dx by dy. So dy by dx equals 1 over that. 8 sine 4y cosine 4y. Now see what it's asking you for. It's asking for square root. So I can start off by saying that that's 8 is the square root of 8. Now, going back to the original expression, up here. Sine 4y is the square root of x, and therefore cosine 4y by a bit of basic maths is 1 minus x. This can get a bit nasty here actually, because what it's asking for is expression of this form. It's not immediately obvious what you need to do here, but you're actually going to do is complete the square. So if I was to simplify that a bit, there we go down to and in order to make things, because I know I'm going to complete the square, in order to get a nice expression, I'd prefer to write it down like that. So then, after completing the square, I then get 1 over minus 64 and just go from there. The actual answer is 1 over 16 minus 64 x minus half squared. And that's really all I want to say really. As I said, a lot of what I've said is just really sort of basic stuff where people lose 1 or 2 marks but just by not really paying attention to what the question is asking really. But anyway, well, I'll write down the exam paper, the website again, where you can get the full worked examples. And thank you very much if you're still with me at this time, and all the best.